Coleman is a company on a mission to fundamentally change construction as we know it today. Coleman's off-site approach to building is dramatically different from conventional construction, and it has many advantages. For starters, nearly all of the construction takes place in a controlled environment at Coleman's 180,000 square foot factory in Lebanon, New Jersey. Building indoors virtually eliminates issues such as weather delays, which commonly plague conventional construction projects. Secondly, by constructing the sections indoors, Coleman is able to build with a very high degree of accuracy, quality, and up to 50% faster. Coleman has implemented successful models from the automotive industry, in particular Toyota's lean manufacturing system. Lean manufacturing is a process developed to create a higher value for the customer by delivering goods and services with a higher quality at a lower cost. By eliminating all waste, such as materials and manpower, Coleman can produce building sections more efficiently and in less time than the traditional building system. The result of implementing this at Coleman is a factory that is amazingly efficient and a product that is of the very highest quality. Recently, over the course of one summer, Coleman completed the construction of 5 new dormitory buildings totaling 41,000 square feet at Muhlenberg College in Allentown, Pennsylvania. Every aspect of Coleman's off-site construction process was planned and predictable, and for the college, this guaranteed that students would be living in the new housing that August. The Muhlenberg project, like all Coleman projects, began with Coleman project managers and engineers meeting with the client and their design team. There are a few basic ground rules when building off-site, but clients and architects agree that they are not limiting factors in designing the building.
Architects can be totally creative. There are no limitations when working with a modular system. We just have to be cognizant of match lines and vertical egress, things of that nature. But floor plans can be wide open, pretty much anything. No limitations whatsoever.
With the plans approved by the client, work began. The drawings were handed over to Coleman architects and engineers, whose job is to lay out each and every aspect of the project using 3D BIM software to coordinate the placement of every building component right down to the furniture. At Muhlenberg, students had scarcely finished their exams, packed up their belongings, and moved out for the summer when the dorms they'd been living in, 7 small wood-framed buildings constructed in 1981 as temporary student housing, were demolished in short order. Once demolition and removal was complete, the construction manager began preparing the site for the arrival of the first sections. This included regrading much of the hillside, addressing substantial drainage issues, and bringing in utilities. Foundations for Coleman's buildings are very similar to those for conventional construction and can include a crawl space or a full basement. All foundations in off-site construction require heavy steel embed plates set in the concrete so the structural steel members of the first floor sections can be securely anchored to the foundation. Once the foundations were complete, utilities were brought into each building. 4 months earlier, fabrication of the buildings began. Raw materials quite literally arrive at one end of the building, while the finished product rolls out of the other. A typical section for the Muhlenberg project began with structural steel beams cut to length with a great deal of precision. The beams were then welded together by certified welders on very accurate jigs to maintain tight tolerances and ensure a seamless assembly on site. After welding the frame together, metal decking was added along with a lattice of rebar. These sections then moved down the factory floor with the aid of overhead cranes. Coatings were applied at this time. Concrete trucks are able to back right up to the Coleman factory, and concrete is poured directly into the floor deck. It was tested on site by an independent inspector. The concrete was then leveled, finished, and allowed to cure. At Coleman, concrete work takes place indoors 365 days per year. As with the floor sections, walls were also welded together on accurate jigs. They were then moved down the assembly line where they were attached to the completed floor sections. The idea is to eliminate waste and increase productivity while simultaneously building with a higher degree of accuracy and quality than conventional construction. The next steps include a myriad of tasks that take place in the factory. Wiring was run within the sections, and electrical fixtures were put into place and connected. Plumbing for the sections was installed. Sprinkler systems went in, and all mechanical, plumbing, and electrical systems were tested. With everything in place, both walls and pipes were thoroughly insulated. Finally, drywall crews went to work, and the section interiors began to take shape. While all that was going on inside the sections, crews were busy on the exteriors. In the case of the buildings at Muhlenberg, this meant lots of intricate brickwork. The plans called for detail in the mortar, accent bricks, and different color bricks between buildings. Extra brick ties were used to secure the brick to the exterior sheathing of the section. Coleman is able to install virtually any kind of exterior facade in the factory, including brick, curtain wall, metal panel, and other rain screen applications. Craftsmen in Coleman's custom wood shop were fabricating and finishing window frames, cabinets, vanities, and other interior finishes, which were then installed into the sections right in the factory. About 1 month after beginning construction, representatives from Muhlenberg, including students and the design team, were able to tour the first completed section. The group wanted to make a design change to expand the sink space and reduce the toilet area to allow several students to use the bathroom at once. Coleman was able to make this design change without a change order for the additional sections, since they had not progressed down the manufacturing line. This would have been impossible in conventional construction. In the design phase, Coleman and the architects decided that the most efficient and cost-effective way to build the gabled roofs was to build each as a single unit on site. The roofs were completed when needed as the buildings were set. In order to ensure that the setting and construction phases of the project ran smoothly, Coleman utilized 4D computer simulation modeling long before the first section was ever set.
4D modeling is a very, very important tool to Coleman. Essentially is a 3D model where the fourth dimension, the 4D, is the time and sequence. What we do in 4D, essentially, we design to scale every single detail, trees, access roads, the actual modules, the crane, and we go through the process to make sure we address any possible conflict between the different components. We were able to find out way ahead that the crane was going to become very close to one of the buildings. And to do that, we had to assure ourselves that the flexion of the actual crane would not get too close to the building. And the way to do that, it was to increase the length of the boom way ahead of before we got there to make sure that we could pick the roof and not interfere with the building.
Coleman realized that setting 90 sections, 5 bridges and 5 roofs in just 10 days, starting on June 14th, was going to be a challenge. A steep slope, a confined space, limited access, and an extremely aggressive timeline of 10 days were all factors that had to be considered. Back at the Coleman factory, each completed section was prepared with a custom cover to protect it from the elements during transport and staging. The sections were then carefully loaded onto trailers. Proper balance and load distribution were absolutely critical, as the largest of the 90 Muhlenberg sections were 13 feet wide by 57 feet long and weighed in excess of 70,000 pounds. While these sections only had to travel 48 miles to Allentown, Pennsylvania, Coleman routinely ships buildings all over the world by boat, trains, and even planes. At the very heart of the setting phase of the Muhlenberg project was a large mobile crane. Kuhlman selects the proper sized crane for each project and positions it to optimize the crane's capacity in order to minimize the time on the project. With the crane properly positioned on the site, the first sections arrived as scheduled. June 14th was a very important day for the Muhlenberg project. The Kuhlman team began their day by checking the load points on the foundations one last time. Then the first section was positioned to be set by the crane. Using a spreader bar, the crane lifted this first section into position above the foundation and set it precisely into place. Throughout the day, more sections were placed, and the first of the 5 buildings began to take shape. One of the more interesting aspects of the Muhlenberg project was the setting of the roofs. Fully assembled, the one-piece roof units measured 55 feet on each side and were 20 feet high. With all the careful planning that went into this operation, the setting of the roofs was accomplished just as intended. Once roofs were placed, roofing crews got right to work to protect the buildings from the elements. At the same time, brickwork started on the exterior mate lines. Over the course of 10 days, workers set a total of 90 sections, 5 roofs, and 5 bridges. Each building is comprised of 6 suites. Most of these suites have 1 double bedroom and 3 singles. Each suite is made up of 3 sections. The largest sections contain the bathroom, kitchen, and living room. The 2 smaller ones contain the bedrooms. With all the sections and roofs in place, crews went to work on the interior mate lines, connecting the mechanical, plumbing, fire protection, and electrical systems. With connections made, the mate lines were completed. At this point, all the systems were operational. Minimal interior finish work was completed, furniture was moved in, and the interiors of the buildings were readied for students. In less than 90 days, students left Muhlenberg for summer break and moved back into 5 brand new buildings with absolutely no disruption to the campus, and a full year sooner than conventional construction would have allowed.
Our client looked to us and said, I can't see how anybody would build any other way. I mean, they got their project up and running in 90 days from the time we took over the site. They're collecting rent a year in advance than what they would have done had they built it conventionally. There's very little disturbance to the site and to the local community, and that's a big deal, particularly in college towns. And it's just a better quality building. It's built in a controlled environment in the facility. It just makes a lot more sense.
The college is extremely happy with the end result of this building process. The buildings are very robust. The look and feel of the building is wonderful. We've had very favorable comments from all of the students I've talked to with these buildings. And I might also say, importantly, their parents have given really high marks to these buildings.
My parents have come up, we had family weekend here. My mother thought it was an extremely nice dorm and it was bigger than they both expected it to be. And then my dad, who's a union guy, he liked how clean everything was and how well done it was.
There's a real buzz on campus about these buildings, and I think next year our lottery system, we're predicting that this will be the premium housing, that these will go the fastest and every student is going to want to live down here in the village.